So, like I said, piece of paper out. Get into things here. Okay. So again, radians and degrees, two different ways to measure the same thing. Think of it like as centimeters versus inches. Okay. They both measure length, right? But they're just kind of like a different measurement of those two things, I guess we'll say. Okay. And we'll start out with the idea here that what I wanted to do right there. Okay. That idea that we kind of introduced during the warm-up, where the circumference of a circle, right? Every one of those circles, if you did about 6 of those radiuses, it would go around the outside of the circle, right? It would go around the circumference of the circle. 2 pi, about 6, right? You said. And so we then said, well, another way you can measure around the outside of a circle, though, is also talking about degrees, right? If you remember back from geometry, you did like arc measures, right? And you talked about like, a certain fraction of the circle would be certain to the degree, of the circle. But then you also talk about arc length, which is like, if you were to actually make the circle and measure it, like how many inches or centimeters it was, like what fraction of the circumference and stuff, okay? But you did talk about, degrees going around the outside of a circle too. And then that, like I said, would then be equivalent to our 2 pi, and we're going to call these now radians rather than radiuses or radii. Okay. So 360 degrees, that around the outside of a circle, right, is the same as 2 pi radians around the outside of the circle, that number of radiuses. Which means then that 180 degrees will be equal to how many radians? Pi radians, exactly right. Okay. Very good. And that means then something like 90 degrees, how many radians would that be? Half pi, or I'm going to say pi over 2. Yep, or 1/2 pi, though, that's fine. All right. Then let's go to like something like 45 degrees.
So what's 1 radian then?
We'll get to that. What is it? Pi over 4, yeah, half of a half, right? So half of a half is 1/4. Okay. What about 20 degrees? Oh, I changed it up a little bit here, but you can still figure it out from here. What would 20 degrees be? So, Grant? Pi over 9. How'd you get that?
I did half of a 4th, so that's an 8, and then it's 1/5 of 4.
Ah, okay. Nice. I got you. Okay. Half of a half. All right. 1/5 of 20. Okay, interesting. Another way you could have gotten that there is the 180 degrees is equal to pi radians, right? You can divide 180 by 9 to get 20, right? And then so pi divided by 9, pi nice. So yeah, but what, of course, if we wanted to come up with something like even stranger than that? So for example, let's say we wanted to convert 21 degrees to radians. Okay, this is a little bit trickier, right? Because it's like, all right, well, what fraction of 180 or what fraction of 360, what would that be? Kind of thing. But 21 degrees, not so easy to see. Okay, and that's one of the big things we want to be able to do today. You should be able to do today is be able to convert from degrees. I'm going to abbreviate with DEG to radians. I'll abbreviate it with RAD. Okay, so how can we convert? Well, it's pretty straightforward actually. We're just going to use a ratio or a proportion, you could say, or really a proportion, I guess. We'll use the ratio of 180 over pi. Okay, a known, or what you should come to know. So you will need to, like, in your memory banks, right, you'll need to remember 180 degrees is the same as pi radians. Or if you prefer, you can remember that 360 degrees is the same as 2 pi radians. Or you can prefer to remember 90 degrees is the same as pi over 2. But you'll need to have one of these kind of conversions down in your head, one of these equivalences in your head, so that way you can then utilize that when you want to convert. Okay? So we have a ratio, right? 180 degrees is the same as pi radians, and the same ratio as, well, the 21 degrees will go up here over, and then we're going to solve for the x number of radians there. Okay? So we'll set up a proportion, starting with a known angle and or degree and radian measure that we know, and then we'll just cross multiply and solve. So we get 180x equals 21 pi. Okay. And then to finish solving for x here, what should we do? Divide both sides by 180. Yeah, so we get 21 pi over 180. Now the 21 and 180, if you want to simplify that, you can. It'll they both divide by 3, right? So we get 7 pi over 60, and that's the best we can do. Okay. If you really wanted to, you could plug this into your calculator. Okay. And the problem is, though, you're just going to get some nasty decimal because we're going to take pi, multiply it by 7, and then divide it by the 60 there. And so you get this. Okay, so approximately 0.366, you know. If you want to say 67 there, I guess that does round up to that. Okay. Of course, we can also take something that's, so we took something that was in degrees and we changed it in terms of radians. We can also do the same thing here. Actually, let me say one more thing, sorry, before I move on here from that. So in other words, what does this mean, right? So if you were to measure an angle, 21 degrees on a circle, right? So let's say you measured off 21 degrees on a circle, maybe using a protractor or something like that, right? It would be equivalent to measuring the radius of that circle and then doing about 0.366 of that radius. And that would be the same kind of distance around the outside of the circle there on the circumference. Okay? So 0.366 of a radius around the circles outside, or 21 degrees. Okay. Let's try another one here. Let's convert 5 pi over 9 radians, okay, to degrees. Oh, yeah, Jeff. Thank you. I didn't realize. Cut it out. Thank you. It's obnoxious. All right, so 5 pi over 9 radians, 2 degrees. I didn't realize that. Doesn't matter now. Thank you, Jeff. All right, so that is a number of radians. Now, a dead giveaway that it's a number of radians, okay, there's no degree symbol, right? So we're talking about an angle. We don't have a degree symbol. That means we are talking about radians then. Okay, that's in radians. Okay, also, typically, radians have a pi in them somewhere, but not always. All right, so same setup here, same setup. We'll do 180 over pi equals, and in this case, our variable will go in what part of the other ratio here? We're trying to find a degree measure, so it should go in the numerator or the denominator? The numerator, right? Because we want to match our unknown degree measure here with our known degree measure of 180, and then our known radian measure in the denominator we'll put here as well, 5 pi over 9. So it is a little bit funky. We have like fractions within fractions and stuff there. Okay, so how do we solve this again? What should we do? Cross multiply. So we'll do pi times x, which is pi x, and then 180 times 5 pi over 9. Okay. Well, we can simplify this a little bit for ourselves, right? So 180 and the 9 can simplify. We can cancel, that'll be a 1, and that'll be a 20. So we have 20 times 5, or 100 pi. Okay. What? No? 180 and the 9 simplified, right? We can like cross-simplify the fractions there before we multiply them out. So the 180 and the 9 becomes 20 and a 1. So 20 times 5 pi, 100 pi over 1. So just 100 pi. Okay. And then final step, divide both sides by pi, so we get x is 100 degrees. Okay. We didn't so we cross-multiply with the proportion. Okay, so the 5 pi over 9 multiplied with the 180, the pi multiplied with the x, and we got this. But then when you're going to multiply the 180 and the 5 pi over 9, when you multiply it with fractions, right, you can simplify the numerator of the one fraction with the denominator of the other. And same thing with this numerator and denominator. Of course, there's nothing to simplify there. But we just simplified the 180 and the 9 before we went ahead and multiplied everything together. Just to make it easier. Lower numbers and stuff. You could have done 180 times 5 and then divided by 9, though. I mean, it's your, you know, if you want to do that. Okay, so 100 degrees, which shouldn't surprise us because we figured out that pi over 9 radians was how many degrees? It was 20, right? And so then 5 pi over 9, well, that's 5 times more radians, right? Pi over 9 times 5 gives you 5 pi over 9. So then degrees, 20 times 5, 100, right? So we get 100 degrees now. All right. So here, let's have you guys try too. So on your own, try. I would like you to convert 300 degrees into some number of radians.
Isn't there a circle that we use for reference, like a radian circle?
Yes.
Or a unit circle?
Yes, we're going to be coming up with that in just a moment. And then convert 7 pi over 6 radians into some number of degrees. I guess I should just put the degree symbol. Okay, so go ahead and give that a try. Take the 300 degrees, put it into radians, take 7 pi over 6 radians, and put it into degrees, please. Okay. And it doesn't really matter which degree and radian measure that you use from the top here, all right, which one you use to compare them. I always use the 180 and the pi, though, because it's like the most simplified, I would say, 180 and pi. Okay. Say one more time? Yeah, if you prefer that. Yeah. Yep, that's fine. Oh, hello. Thank you. Okay, so this, just this whole thing, huh? Okay, or however much it is. So there was there were 2-point word problems too on the other paper.
Yes, there's one.
Okay.
One of them was that.
Okay. We'll do that.
Yeah.
Okay. Oh, here? Okay. Yeah, that's good. Okay.
So it's good.
Yes. Right. So no word problems with this today, except for that one. Yeah, okay. Okay, I don't know if we, yeah, I don't know. Okay. Just make it up. You should work on it perfectly. Okay. Deep, 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 deep. Okay. Jeff. Is that an appropriate thing to be doing in class right now? All right, cut it out then. And especially if someone asks you to stop, you should really respect that. Rule number 1. Okay. Jenna F. What do you say, Jenna F? Did you get 1 or 2 done?
Yeah, I got 1 done.
1? Okay. Do you want to give us an answer? Sure.
So I got 5 pi over 3.
5 pi over 3. Okay. So actually, I don't know why I'm writing it on the board here. But on the paper. Yeah. So 5 pi over 3. All right. Very good. Any questions on that one? We're all good with that? Yeah? Okay, good job, Jenna. And let's go to then May number 2. 7 pi over 6 radians. Did you get a degree measure for that? 210. Okay, are we all okay with that too? Okay, yeah, that's right. Good job. All right. No questions on those two then? Feeling good so far? I have one more kind of little concept I want to throw at us here too. Okay, and it has to do with the idea of coterminal angles. So Jeff, I said we're going to get to the unit circle today. We're going to do that tomorrow actually. All right, but today, for our last little bit here, I want to talk about something called, like I said, coterminal angles. Okay. So, again, mathematics, right? When you come up with a vocabulary word, we're not very creative with how we come up with words here. It's basically just, it says what it is, right? So co, share, right? And a terminal, you normally think as like the ending of something, but the word terminal, right, shows up in like an airport, right? But in an airport, don't you both start and stop your journey at a terminal, right? You fly out on your trip, but then you also fly back from your trip and you go through a terminal as well. So while yes, the word terminal typically means like the end of something, it also can mean the beginning in a sense too, or at least with the trip and stuff like that. Does that what it means?
I don't know.
I don't know either.
It can mean start or end, but both are technically the end of a journey. I mean, just like
the end of one journey, the beginning of another kind of thing.
Yep.
I see what you're saying. So I don't know, but either way, okay. So they share. That's true. They share the same starting and ending positions. Okay, so these are angles that share. So that's the co part. The same starting and ending positions.
I was hoping someone would say, "Put that stupid tongue in your mouth." That's what my grandma used to say.
Oh, is that right? Well, I don't know. Tongue's not smart or dumb, I guess. It's the person that's using it. So, that's what a coterminal angle is, right? So, for degrees, all right, we're going to talk about what a coterminal angle will look like here. So let's just imagine, before we get to that, I'll fill in a blank here. We're going to put something right in here, okay? Let's say that we've got an angle. I'm just going to draw a little geometric angle here. All right, and we'll say that the interior angle here is 30 degrees. Okay, 30 degrees.
That means that the coterminal angle would be
330? That would be, yes, kind of. So we want to be a little bit careful here. So notice here that my angle, right, here's my starting side of my angle, we'll say, okay, the terminal side. And this really has to do more with like, I guess I should really say, yeah, maybe do I want to be this specific? All right, well, anyway, let's just say this is 30 degrees for right now, okay? We'll say it's a positive 30 degrees. We're opening up in a counterclockwise direction, so we'll say that's a positive 30 degrees, okay? We'll talk about like directions of angles a little bit more tomorrow, I think, too, but anyway. Yeah, they do when we're on the coordinate plane, at least. We do when we're on the coordinate plane. But anyway, so 30-degree angle, right? But what I could also do to get in this same, to have the same starting point and the same stopping point here, I could go 360 degrees around so that I'm like back to where I started and then go 30 degrees more. So if I started here, went full rotation, and then an extra 30 degrees, okay, so again, that 360, I'll mark that there in red, okay. What angle would that be then? 360 plus another 30 would be what?
390.
Yeah, 390. Okay. So in a certain sense, a 390-degree angle is the same as a 30-degree angle. I don't know if I want to say it's the same, but they're very close to each other, right? And they have the same starting point and stopping point, okay? Right? And so if you were to like do a 30-degree angle and if you were to measure off a 390-degree angle, they would look roughly the same, okay? Because they have the same start and same stopping point. Okay? And of course we could continue. We could find more coterminal angles, right? I could add another 360 or another 360 or another 360. Or I could go around this, 10 times and then go 30 degrees more and I'd be right back to where the ending point was right there. Okay. And of course, instead of adding 360 every time, what's another option that we could do? Instead of adding 360, we could do what? Subtract 360. Right, we could go the opposite direction here. I think my green pens are over here. Oh, wait. One here? They maybe go out. Alright, nice. Let's see. Good. Okay. So right, alternatively to going, more in the counterclockwise direction, I could also go in the clockwise direction, like around this way. Okay, and right, that would be then 330 degrees. And because we're going clockwise, we're going to call that negative 330 degrees. Okay. So yeah. So we could take that 30-degree angle and subtract 360 from it to get that negative 330-degree angle there. Okay, like so. All right. And so that's how we can come up with both positive or negative coterminal angles. You either continue to add or subtract 360 degrees until you reach another positive coterminal angle or another negative coterminal angle, right? And it can be multiples, right? You can add multiple 360s or subtract multiple 360s. And so you really can come up with an infinite number of coterminal angles for any given angle, either positive or negative, okay? So I'll write this here. So 390 degrees and negative 330 degrees, okay, are coterminal to 30 degrees. Okay. So try your different colors there, but it doesn't quite show up. The green doesn't quite show up that well, but you get the idea. Okay. And so, of course, then, if we can add or subtract 360 degrees for angles that are in the degree, right, and the units of degrees, what do you think we would add to radian measures then? What can we add or subtract to radian measures to get coterminal radian measures? What's equivalent to 360 degrees in radians? 2 pi. So we can add or subtract 2 pi for radians. Okay. Or if you want to make it really difficult, not really difficult, if you want to make it more work for yourself, you could take a radian measure, convert it to degrees, add or subtract 360, and then reconvert it back into radians. But that's a lot of work. Okay.
Where would you do that?
So you could just add, for example, 7 pi over 6. Okay. 7 pi over 6, we can take that, which we know is the same as 210 degrees, right? We converted that earlier. Right? We can take 2 pi over 6 and add 2 pi to it. Of course, to add 2 pi to this, can we add these right as they're written right now? No. Yeah, we need common denominators, don't we? So we'll keep that 7 pi over 6, and 2 pi becomes what in sixths? 12 pi over 6, yeah. And so then we have 7 plus 12 is 19 pi over 6. Okay, which is coterminal to 7 pi over 6. Okay. And of course, we can keep adding, right? We can add another 12 pi over 6 and get 31 pi over 6. In case sometimes, why would you do that, right? So sometimes, like a common direction or a common thing you'll be asked to do is to find like a positive coterminal angle and a negative coterminal angle. So obviously here I already have a positive coterminal angle. So what I should do is not add 12 pi over 6. I should subtract 12 pi over 6. So in other words, I could subtract 12 pi over 6 there and get negative 5 pi over 6. And it'd be in the same position as the 7 pi over 6. You can 31 pi over 6. Yeah. That's another one. That's if you add another 2 pi, you get that. Okay, like 19 pi over 6 plus 2 pi would give you the 31 pi over 6. So it's just more coterminal angles is my point. That's all. Or we could, again, instead of adding 12 pi over 6 to 7 pi over 6, we could subtract it, and you get the negative 5 pi over 6 then. Okay, so that's the idea there. You're either adding or subtracting 2 pi to get those coterminal angles. Okay, so that's it. All right, that's all we're going to learn for today. Okay, so the big takeaways here, make sure that you can convert from degree measures to radian measures, okay? Typically using, you know, the proportion, ratio proportion stuff. And then make sure you can also identify coterminal angles. That is, that would be angles, right, that are in the same position, same starting and stopping position as whatever your given angle is. Okay, doing that both with degrees and radians as well. All right, and that's where we're working our major focus today. Okay, questions on any of that? All right, so let me then show you what you'll be doing for your assignment then here. Okay. It's going to be out of the book, so if you want to pull that up.